Hi guys, welcome to SciStar's tutorial for how to determine the pH for a strong acid and strong base solutions. These are going to be pretty common in your upper chem classes, so it's important that we know how to do these problems and understand the chemistry going on behind the scenes. So I will teach you my process, the equations that are associated with my process, and first, it's really important that we know that we can identify strong acids when we see them, as well as strong bases. For strong acids, I remember it as CSI on NBC, so HClO4, H2SO4 for the S, I would be HI, N would be HNO3, B would be HBr, and C is HCl. It's just one quick, easy way to remember those 6 strong acids. We can assume everything else is a weak acid. Finally, for strong bases, we can remember them as group 1 hydroxides. Oh, I don't know why that Y was so low. As well as CaOH2, BaOH2, and SrOH2. Okay, now we're going to go on and learn the process. My process begins with determining what our major species are. So, what does that mean? We're going to try to think about what do we have in solution. What species are major? What do we have a lot of? When we have a strong acid and a strong base, because they completely dissociate, we're going to have that H+, which is going to be converted to H3O+, because again, our water is going to act as a base and steal that proton. So we're going to have major species of ions, H3O+ or H+, which are synonymous, and water. Then we're going to pick our strongest acid or base in solution. Finally, we are going to determine our concentrations of that H+ or that H3O+. And finally, we can apply our equations, which will be as follows. So pH plus POH equals 14. So that is an important equation that relates our concentrations of H+ or OH- and our pH to our POH. Also, pH equals the negative log of the concentration of H+. Finally, POH equals the negative log of the concentration of hydroxide ions. So again, strong acids, strong bases, they completely dissociate. So for our process, first, what is the pH of a 1.63 molar HCl solution? So I'm going to highlight that and say, okay, we're dealing with a strong acid. It's going to completely dissociate. Therefore, our major species are going to be H+, Cl-, and H2O. And remember, this H+ is going to become one with water, so they'll become H3O+. Now, let's determine what our strongest acid in solution is. That would be our H+ or H3O+. And we want to determine that concentration, and because HCl completely dissociates into H+, we already know our concentration of H+, which is 1.63. And remember our equation, pH equals the negative log of our H+ concentration. We're just going to sub that number in, and we are going to get our pH to be, let me just solve for that really quick, negative 0.212. And remember, it is okay to have a negative pH. It can happen. It just means it's super acidic. We can also have pHs well above 14. Now, for our concentration of OH-, we're going to have to convert our pH into POH first. So we know 14 minus our pH will be our POH. So if we sub in that answer that we just got, so minus a negative number, oh my goodness, why am I having so many problems? So if we sub in that negative number, we will get our pOH to be a positive 14.212. And now when we have once we have our pOH, we can solve for our concentration by undoing a log. So let me just get rid of this. So now we know our pOH is 14.212. We're going to set our pOH equal to the negative log of the hydroxide ion concentration. We're going to sub in our 14.212 here, and it's there. We're going to move that negative over just because it makes it so much easier. So we have 14.212, which is negative now, equals log of the concentration of OH minus. And then to undo that log, we're going to use 10 to the power. And when we do that, we're going to get an answer of 6.1349 times 10, oh my goodness, times 10 to the negative 15th molar as our answer. Circle that. So for this next problem, what is the pH of a 2.78 times 10 to the negative 9th molar HNO3 solution? So CHNO3, I think strong acid, and then I see this and I automatically think our major species is going to be pretty much water because this is so diluted. It's like dropping a single drop of HCl into a pool. It's not going to change the pH overall, like at all. So our pH is technically just going to be 7 for this problem. It's neutral. So for this problem, what is the pH of a 1.89 molar HClO4 solution? So we're dealing with a strong acid. So again, strong acids completely dissociate. So let's go through our steps. Determine the major species. It will be H plus ClO4 minus and H2O, because we're putting that into solution. 2. So our strongest acid, which in this case will of course be that H plus or that H3O plus, because remember the water is going to act as a base and accept that proton. So since that is our strongest acid, we want to find that concentration of H plus or H3O plus, which we automatically already know because our acid completely dissociates. So it's 1.89, and then we can apply the equations, and we're going to get, remember our equation is pH equals the negative log of the concentration of the concentration of H plus, which we know is 1.89. And when we plug that into our calculator, we get our pH to be negative 0.276. That just means it's super, super acidic. So for our next problem, what is the pH of the pH of blood is 7.41. What is the concentration of H plus? So this problem requires that we work backwards a bit. So we know our pH equation. Let's write that out. pH equals negative log of the concentration of H plus. We know that again our pH is 7.41. We're going to plug H plus. Okay, now we're going to move the negative over by dividing by like a -1. So it will be, negative 7.41 equals the log of H plus. We're going to undo that log with the 10 to the power function. That will cancel out, and for this problem, we're going to do 10 to the negative 7.41 power, and we get our H plus concentration to be 3.89 times 10 to the negative 8. So for that problem, we had to work a bit backwards and undo logs. If you're not comfortable, please brush up on those skills. They will be really important in these kinds of problems. So for dealing with the strong base, we're going to essentially use the same process but convert our POH to pH. So what is the pH of a 2.43 molar KOH solution? Major species, again, strong bases completely dissociate, just like strong acids. So we will have K plus, OH minus, and water. Strongest base is going to be OH minus. Determining that concentration of OH minus will be very easy because we already know that our KOH completely dissociates. So I'm going to rewrite this. So it's going to be 2.43. Remember, all this KOH completely comes apart, essentially, because it's a strong base. We will have 2.43 molar concentration of OH minus. And now that we know our concentration, we can apply the POH equation. Which this is our POH equation. We're going to plug 2.43 in here. I'm going to erase all this just so we have more room. And then when you solve, we're going to plug this concentration in here. And then when you solve, you get the POH to be the negative log of 2.43. Negative 0.3856. And then if we want to convert this to pOH, remember 14 equals our pOH plus our pH. So we're going to have this 14 minus a negative 0.3856 equals our pH, which will equal 14.385 pretty much. I'm going to get rid of this so we have more room, and this should make sense. Remember, on that scale, when you have this scale, 7 is neutral. Anything greater than 7 in this area is going to be basic, which means we have a super basic solution here, and which makes sense because we have a strong base, and then on this side, this stuff would be super acidic because it's less than 7. So just think about like the scale, and after you get your answer, like think, does this make sense? So for this problem, what is the pH of a 2.43 molar BaOH2 solution? We remember this is a strong base. It's going to completely dissociate, except because it's OH2. It means that we have double the moles for every salt. Every Ba ion we have, or cation, we have 2 moles of that OH hydroxide minus ion. So our pH, or let's go through our steps first to solve for that pH. So major species is Ba2+, and that OH minus and water. This will be our strongest base. So then we want to know what our concentration of that strong base is. We already know 2.43 molar is how much strong base we have, but because we have 2 moles of hydroxide ion, and we want to find this concentration, we have to double that. So 2.43 times 2 will be 4.86 molar concentration. And then we want to plug that into our POH equation, which is the negative log of the concentration of OH minus, which we know is 4.86. Take the negative log of 4.86, and we get negative 0.686. And then when we want to find our pH, we just know we have to subtract that negative number. So we get our pH to be 14.686. And because it's greater than 14, we know it's going to be a super basic solution. And that is it. Remember to subscribe, hit that like button, and turn on notifications. Thanks for watching!